Today, we are going on an incredible journey. We're going to trace the history of the computer, from these clunky, gear-driven machines of the past, all the way to the sleek, powerful devices we carry around in our pockets. So, let's dive in.
I mean, really think about that for a second. The phone or laptop you're using right now, it's literally millions of times more powerful than the computers that guided the Apollo missions to the moon. It's wild. To really get how we made that leap, we need to trace the evolution of the hardware. And along the way, we're going to build up our technical English vocabulary so you can talk about it like a pro.
So here's our roadmap for this explainer. First, we'll start way back, in the purely mechanical age. Then, we'll jump into the electrifying revolution of the 20th century. After that, we'll see how technology started to shrink at an unbelievable rate. And we'll wrap it all up by putting together a solid vocabulary toolkit for you.
Okay, first stop. A time before a single spark of electricity was used for computing. Welcome to the mechanical age.
That's right. Long before we had silicon chips and circuit boards, you had these brilliant inventors creating tools to do math using physical parts. We're talking about things like the abacus, or even incredibly complex machines full of gears and levers, all designed to crunch numbers. These were the true ancestors of our computers, and they ran on nothing but physics.
All right, so let's focus on our first key term here, mechanical device. Now, in a professional or academic setting, this is what you'd call any machine that works using physical motion. Think gears turning, levers pulling, springs coiling. There are no electronics at all. It's all about the physics of movement, plain and simple.
But then, everything changed. Once we figured out how to harness electricity for computing, the game was completely different. This brings us to the electronic revolution.
So, these early electronic computers, like the legendary ENIAC, were just colossal. I mean, it filled an entire room, weighed 30 tons. That's like 6 elephants. And the heart of this beast was thousands and thousands of little components called vacuum tubes.
Let's break down that term, vacuum tube. The easiest way to think of it is like a small, fragile glass light bulb. It could be switched on or off, which was perfect for representing a 1 or a 0 in binary code. But while they were revolutionary, they were a nightmare. They were huge, they got incredibly hot, they burned out all the time, and they used a ton of power.
You know, the scale of these early machines is it's hard to wrap your head around. On the left, you're looking at a computer that needed its own building. We call these massive machines mainframes. Now compare that to the supercomputer that you carry in your pocket. The difference in size and power is just absolutely staggering.
And you know, the term mainframe is actually pretty literal. It got its name from the huge metal frames or racks that held all those vacuum tubes and all that complicated wiring. These were the workhorses for big government agencies and corporations, just chugging away, processing enormous amounts of data. So all of those problems with mainframes, the crazy size, the power they ate up, how unreliable they were, that wasn't just a headache. It was the direct motivation for the next great leap in computing, the age of miniaturization. The goal was simple, really: make everything smaller, faster, and cheaper. And this evolution happened incredibly fast. You can see it right here. The problem was obvious: these big, hot, clumsy vacuum tubes. The solution was an absolutely brilliant invention called the transistor. And that solution led to a full-blown revolution, putting tons of transistors together into something called an integrated circuit. And this brings us to the transistor. I'm not exaggerating when I say this is probably one of the most important inventions of the 20th century. It does the exact same thing as a vacuum tube. It's basically an electronic switch, but it is tiny, it's solid, it stays cool, and it's incredibly reliable. You can almost think of it as a tiny, perfect, solid faucet for electricity that you can turn on and off instantly.
So, the next thought was pretty logical, right? If one transistor is great, what's better? Well, what about hundreds or thousands? Or, hey, what about millions, all working together perfectly? The huge breakthrough was figuring out how to build and connect huge numbers of these transistors on one tiny little piece of silicon.
Which brings us to our next essential term, the integrated circuit. You'll often hear it called an IC or just a chip. The magic word here is integrated. It means all the parts, the transistors, the connections, everything, are combined into one single seamless unit. This idea is the very heart of miniaturization. And this is the amazing result of all that integration. What you're seeing is a microprocessor. It's the entire central processing unit.
the actual brain of a computer on a single chip. And it doesn't have thousands of transistors, it has billions. Every single smartphone, every laptop, every modern device has one of these.
Let's break down that term, microprocessor. The prefix micro, well, that's easy. It means super small. And processor just refers to its job, the central processing unit, or CPU. So it's literally a tiny processor, a complete revolution that grew out of the integrated circuit.
You know, a quote from our source material just sums up this entire journey perfectly. It says, "Each generation results in products that are smaller, cheaper, more powerful, efficient, and reliable." Every single step we've just talked about was driven by that relentless, unstoppable push for better.
Okay, we have covered a ton of ground. So let's wrap this up by reviewing that essential vocabulary. This is your toolkit for talking about hardware history, whether it's in a classroom or a professional meeting.
You know, this list really tells a story, doesn't it? We began with those huge mainframes that ran on thousands of unreliable vacuum tubes. Then the tiny transistor appeared and changed everything. That led to the integrated circuit, which is just many transistors on one chip, and that ultimately gave us the microprocessor, the brain inside every modern computer.
It really is an incredible story of human ingenuity. When you step back and look at it, we went from needing entire buildings to house a single computer to having devices that slip right into our pockets. It's a journey of non-stop innovation, and it's still accelerating today. And that whole journey leaves us with one last, really fascinating question. We've watched technology shrink from the size of a room down to the size of a wallet. So, what does the next chapter in the history of hardware even look like?